Welcome to FuzzyTek, the show where I talk about technical, geeky, nerdy stuff. I'm Fuzzy, and in this episode, I'm going to go back to the very first project on this channel and give you some updates and progress. If you haven't seen the first Nixie Clock Project episode, which also happens to be the very first episode of FuzzyTek, go give that a watch to get an overview of the project. You can also check out the second and third episode to see more about how the clock works and view some of the code. Links are in the description. At the end of the last episode, I was putting the project into a wooden box and wiring up all the Nixie tube sockets. I've since repurposed the wooden box and I'm going to desolder all the wires on the sockets, as I've changed my mind about using that particular box and method of connection. Plus, my hole cutting was absolutely dreadful to say the least. Instead, I've created a proper schematic and then from that a couple of circuit boards. The breadboarded project from the very first episode has sat the way I left it ever since the episode. Nearly 3 years later, I finally decided to pull it apart, ready for putting on the circuit board. There are two circuit boards for one clock. One of them holds the tube sockets and Nixie chips, the Soviet era K155 ID1s, as well as two neon lamps that will blink at a 1 Hz frequency once every second, which is output from the real-time clock chip on the other board. The boards also take high voltage of about 180 volts from the converter to power the tubes and the neon lamps. The other PCB holds the 80 mega AVR chip that will contain all the code. It also contains the DS1307 real-time clock and its battery backup, as well as two shift registers that send the data from the AVR to the Nixie chips, and some headers for external input, such as a rotary encoder and a push button. The two boards will connect together with a 30-pin cable to transfer the data and 5 volts and ground between them. As the code stands currently, it's pretty much the same as in the previous episode, but there are 2 pins set ready for the rotary encoder. I haven't yet coded this, but it will be for changing the hours, minutes and seconds to set the time and date manually, as right now the time is set for the first time by the computer when the code is uploaded to the chip, and then it's kept by the RTC battery. If the chip loses power, it also loses the date and the time, so I think having an option to set it manually is a very good idea. I'm no expert by any means, but from my understanding, a rotary encoder works like so. Inside the device, there are contact pins, and when you turn it, these points come into contact with the common ground pin. I've used this image from lastminuteengineers.com to demonstrate, as I thought it was a great example. The full article is linked in the video description. When turned in a clockwise direction, the first pin comes into contact, and then the second pin, and so on, creating a reading of high then low. If you were to turn it the other direction, the second pin would connect first, and then the first pin, creating a reading of low and then high. This can be used to determine in which direction the encoder is being turned. Here in the Arduino IDE, we can see where I've set the encoder pins. So far, that's all I've done for the encoder side of things. Once I received all the parts, I put the board together and wired it all up. It turns out that the minute digits didn't work. After poking about with the multimeter, I discovered that for some reason the ground points on the middle 2 Nixie chips weren't connected to the ground plane, but they were connected to each other. So to fix it, I soldered a wire connecting it to a neighbouring chip. Turned it all on again, and they still didn't work. To cut it short, it turned out to be the first shift register on the other board. A few of the connections were off, but a few fixing wires later and it was glowing in all its goodness. The time wasn't correct, of course, as I still needed to set up the rotary encoder and button to set it. But at least it works. Apart from the divider lamps, I don't know if I messed up some of the traces or if it's something to do with the code. But I'll look into it last, as it's not the most important thing and I'm not too bothered if I have to leave them out in the end. So the basics of the clock work, and all that's left to do is set up the encoder and button to set the time and date, try to fix the divider lamps, and then find some sort of case to put it all in. I guess that's it for this episode. If you like what you see, please give it a like. If you don't, please tell me why, and consider subscribing and pressing the bell. Many thanks for watching, and until next time. Bye bye.